What is a regular polygon? Now, all a regular polygon is it's a polygon in which all of its sides have the same length and all of its angles have the same measure. That's all a regular polygon is. So, a four-sided regular polygon will look something like this. See if you can predict what it looks like. Looks something like that. So pretty much a four-sided regular polygon. All four sides have the same length. All four angles have the same measure. And in that case, it would be a square, right? Now, a five-sided regular polygon could look something like this. Right? Assuming all the sides have the same length and all the angles have the same measure, that would be a five-sided regular polygon. And we'll do one more. A six-sided regular polygon would look something like that, right? Assuming all the sides have the same length and all the angles have the same measure, this could be a six-sided regular polygon. Now, our goal in this video is to figure out, based on the number of sides a regular polygon has, what would be the measure of one of its angles? How do we figure that out? Now, the way we're going to do that is we're going to do a really interesting approach to this. We are going to divide our regular polygons up into triangles, because we know the sum of the measures of the angles in a triangle, right? The sum of the angles in a triangle is just 180 degrees. And we're going to use that idea to figure out the measure of an angle in a regular polygon. So for example, what's this angle? Given that this regular polygon has five sides, what would be the measure of this angle? Given this regular polygon has six sides, what would be the measure of one of its angles? That's our goal in this video, to figure out, based on the number of sides a regular polygon has, what would the measure of one of its angles be? Now, the way we're going to approach it, we're going to divide our regular polygons into triangles. So, the way you can do that is just choose any point inside of the regular polygon. For example, right there. Right? A regular polygon will always have an interior that should be able to reach each of the corners. So, for example, I'll just choose any point inside the polygon. Right? That's all we have to do. Any point. And then next what you want to do is you want to take that point and connect it to each of the corners of the regular polygon. So, for example, right here, I'll just connect it to that corner, to that corner, to that corner, and to that corner right there. Right? Assuming those are straight lines, and we'll do it for the next one. Right? Just connect to each of the corners. Right, looks pretty good. For the hexagon or six-sided regular polygon, I'll do the same thing. Connect that point to each of the corners. And so the next thing that I want you to notice is how many triangles we formed in each of our regular polygons. We have formed 4 triangles, 5 triangles, 6 triangles. So the number of triangles that are formed are based on the number of sides the regular polygon has. Remember, our goal is to figure out, based on the number of sides a regular polygon has, what would the measure of one of its angles be? So like this entire angle from the blue side here to the blue side there, what would the measure of that angle be based on the number of sides? Well, the way we can do that is, first we could start off by adding up each angle inside of this regular polygon, meaning every single angle. And the way we would do that is we would say 4 triangles times 180 degrees, because each triangle has a total of 180 degrees. And so we would say, for this pretty much the 4-sided regular polygon, we would start by saying 4 times 180, actually I'll use a different color, 4 times 180 degrees. Because we have 4 triangles here, and each of those triangles has a total of 180 degrees as the sum of its angles. Now, remember, we only care about the measure of, let me show you, we only care about the measure of one of these angles right here, right? We don't care about these angles right here. See those angles? We don't care about the ones that don't touch the polygon, because these ones don't touch our 4-sided polygon. So we want to get rid of these angles that intersect at this point right there. Now, the way we do that is we know that the sum of all four of these angles right here that are surrounding our point, that's 360 degrees, right? Because it forms a circle if we add up all four of those angles. So we want to subtract that 360 degrees, right? So we subtract that 360 degrees. So what that does is we're now only dealing with let me show you, each of the angles, right? We're dealing with only these four angles, right? We're dealing with, technically it's 8 angles. This one, 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 this one. We're now only dealing with the angles that touch our four-sided polygon. We're not dealing with these ones because we got rid of them by subtracting 360 degrees. So all we're left with is those four angles right there. But remember, we only want the measure of one of those angles. So all we have to do is we divide by 4, because there's a total of 4 of those angles. To get only one of those, we just got to divide by 4, and now we're only dealing with one of them. So we divide by 4. This expression right here would give us the measure of one of those angles. And we could do the same thing for our pentagon and our hexagon. For our 5-sided regular polygon, we have 5 triangles. So our total angles would be 5 times 180 degrees. Subtract the 360 degrees at that intersect at the point, right? Subtract that 360 degrees. And that means once we subtract that 360 degrees, the only angles we're dealing with are the angles that touch the regular polygon, right? The angles that touch, those 5 angles that touch the regular polygon. And since all the angles are the same measure, all we have to do now is divide by 5, because we have a total of 5 of those angles. We just got to divide by 5, and then we're only dealing with one of those angles. So that would give us the measure of one of those angles in our pentagon. Same thing can be done with our hexagon. Total of 6 triangles, so total amount of angles, 6 times 180 degrees. Again, we subtract our 360 degrees at the center, so subtract that 360 degrees. And so that means we're only dealing with, once we subtract that 360 degrees, we're only dealing with the angles that are present touching the actual polygon itself. And so to get the measure of only one of those angles, because that's all we care about, we just have to divide by 6, right? Or divide by 6, we'll get the measure of one of those angles. And so it turns out this would be true for whatever regular polygon that we did. And so as a result, you can kind of see how each of these expressions that we made are really similar to each other. Here's how we can do this. We could rewrite this by saying, right? I'm just saying this. We could say, right? We could write a general expression for what each of these could be, right? For any regular polygon. Notice how we have 4, 4, 5, 5, 6, 6. Well, that number that we put there actually has to do with the number of sides the regular polygon has. So pretty much I'm going to use the letter n, right? I'll call this, it's a variable, of course, where n represents the number of sides that our regular polygon has. We always multiply by 180 degrees, right? We always did that. And the reason why is because it's our triangle, right? Always multiply by 180 degrees. And we always subtracted 360 degrees because we're subtracting those angles that we didn't care about, so the ones that intersected at the point that we made. So we subtract 360 degrees. And so as a result, this is the expression that will give us the measure of one of those angles in any regular polygon, right? Think of like a 10-sided regular polygon, the thing that's called a decagon. You could figure out what the measure of one of those angles would be. You just have to use that expression. And so we figured it out. And what many people like to do is they like to factor out the 180 degrees at the top. All right? They like to say, technically I could say it's equal, right? It's equal to, factor out 180 degrees, and so you get n minus 2 in the parentheses, right? All divided by n. And so they like to use this expression that helps us figure out the measure of one of those angles. And so this expression right here, given the number of side lengths, or given the number of sides in a regular polygon, you can figure out the measure of one of those angles in a regular polygon by using that expression. And that is it.